Okay, so your problem basically is that you have to figure out, let me just pull this up. The glass of soda, they divide it in half, then they divide it in a third, and divide it in a fourth, divide it in a fifth. They do it 99 times. So the first time they do it, they're halving it. The denominator's 2. The next time, second time they're doing it, they're thirding it. The denominator's 3. And we need to figure out what the bottom denominator is in the sequence, so that you figure out how much goes in each glass. So let's show you what I did. Tara helped me with this. So first thing I did is I wrote down 100 or 99 pours. So what I want to do is show you I put 99 pours here because I got to figure out where the fractions fall for each one. The first one obviously was in half. So in this column, I wrote the denominator 2, 3, 4. So I could see it breaks in half, third, fourth. Scrolling to the bottom, the last one turns out to be 100. So we have an even number of pours. And that's going to turn out to be critical at the end. So I need 1 over 2, 1 over 3, 1 over 3. I need as a fraction, and then there's a percentage. So I wrote a little formula here, pretty stupid. 100 divided by this, which would be 2, times 0.01 will give me a percentages. And I figured out the percentages. I didn't show all the decimal places. Some of these are fractions of percentages, but it does the math right. It just doesn't show it on the screen and make it easier. So the next thing we did was figure out that when it's odd, it's going from Emily to Alice. When it's even, it's coming from Alice to Emily. So we wanted to show the amount of fluid change in this column for each girl. So it doesn't tell you whether it's being added or subtracted, just how much fluid is going to change. So it's how much of what they originally had is going to change. This is the running total like you have in a checkbook. This is the amount of each transaction, if you will. So what we do is, in the case of odds, we are subtracting here. In the case of evens, we're adding. Subtract, add, subtract, add, subtract. Now, instead of me writing a gazillion formulas, I did an if-then statement. So I said that if the line number or the pour is odd, if it's odd, then subtract from this side. If it's even, then add to this side. And I did the inverse here. If it's odd, add to this side. If it's even, subtract from this side. And that's the way the formula reads. I used a formula called mod. And when you divide something by 2, a mod, so it's mod. Let me show you an example down here. Just these aren't really calculated, but if I mod the number 2 by the number 2, the divisor is 2. It comes out with no remainder. If I mod 3 with a 2, it'll come out with a remainder. So whenever I mod something, it comes out with a 0. When I mod something by 2 and it comes out with a 0, that means it's an even number. I couldn't get there's a formula in here for odds and evens, but I couldn't get it working, so I just did this one. So when you look at a line and you see a formula like this one, all of this in the beginning is saying, is this an even line? Okay? If it is, then do this. If it's not, then do this. So that's all that's doing. You can ignore that and just understand it's checking to see if it's an even line. So in the first case, we want to record here what the fluid change is going to be. If it's an odd row, which it is, it's going to do this formula where it takes this amount and it times it by the percentage and puts the number here. So 50 ounces is going to change. This side says if it's odd, just take their number because they're the one figuring out based on how much they have in their glass, how much is going to change. And you just take it over here. The inverse is also done. When we go to an even line here, it's going to take this percentage of this number and put it here. And then this side, because they're taking that out, has to accept that here. So that's what that formula does. So how does the math work out? Well, basically what happens is you start out with 100. The first time you pour is an odd number row. So it's going to figure out 50% of 100 is 50 milliliters or ounces, whatever you're doing. It's going to put that in both columns. And then because this is an odd row, an odd subtracting, we'll take 100 minus 50 equals 50. So she's left with 50. She's got 0 plus 50. She's with 50, so we're even. Even Steven. The next one is going to calculate again. It's going to figure out it's an even row, and it's going to take 33% of this number, which is 33% of 100 is 33, so 33% of 50 is 16 point something, running 16.6666. So it takes that away from her 50, and it adds it over here. So you'll see we're out of balance now. But we're going to go down to the next row, which is again is an odd number row, and we're going to figure out a smaller fraction, but of the bigger amount of fluid. She's got 33, she got 66. 25% of 66 is 16%. And if she pours that back in, she evens them back out again. Ironically, the way they chose the fractions, incrementing the denominator by 1, evens it out every single odd pour. So every time Emily pours into Alice's, Emily has more fluid but a smaller fraction, but just the right number to even at 50% again. And you can see that all the way down 50, 50, 50, 50, 50 to even all the way out. So all I did was write this formula and then drag this down, and it copied into all the columns. It was no big deal. So the key, ultimate key that played into place is they said they do it 99 times. Well, that comes to an odd row, which again is Emily pouring, what's her name again? Emily into Alice's glass, evening it out again. So ironically, at the very end, they even it out once more. That's how we figured it out. There is a sequence formula. I don't know what it is. I'm sure they're going to teach you it. That you can do this in a formula a lot simpler than what I just did it. But it basically breaks down, since it's only 99 times, and I can drag and drop in Excel. It only breaks it down simple for us here. But if you had thousands of these to do, obviously you'd want that formula. So hopefully that makes sense to you.